Okay, this is day 2 of the analytic property of conic sections. And I think it's useful to have the properties handy. I mean, you don't have to print them out, but you can have them handy so you can use those equations as you need them. Okay, let me center up here. All right, first example, number 27. Off of the same paper from yesterday. Given information on number 27, it says it's an ellipse, vertices of 4, -2, and 4, 8, and a minor axis is equal to 6. Now, minor axis is the distance all the way across the ellipse. The shorter the distances from vertex to vertex. Okay, well, if that's all the way across, then the minor radius is going to have to be 3. Okay, now for the rest of it, let's take a quick look at what the given information when plotted looks like. All right, so we're given 4, -2 as a vertex, 4, 8 as a vertex, and it's easily calculated that the center is halfway between the two of those, which is 4, 3. Now if we go 3 units in either direction, that'll put us at 7, 3 and 1, 3 for the other vertices. And here's our ellipse. Okay, by inspection, the distance from here to here is 10. So that makes 2a is 10. It's twice the major radius. That's called the major axis. So a must be 5. In an ellipse, a squared is equal to b squared plus c squared. Using these two values in there, c is 4. D, if you look at the properties, a squared is equal to cd. That can easily be isolated for d. D is a squared over c. So d is 25/4. Now 25/4 is longer than 5, so these directrices, of course, are outside of the ellipse. And I plotted those yesterday on Desmos, so you can do that if you want, but I don't think it's necessary. You should realize that. Okay, the equation, and you can write the equation in any form you want, but we'll do a little bit of practice here. X minus 4 over 3 squared. I'm just taking the information right off of the diagram. Plus y minus 3 over 5 squared is equal to 1. Now I can use the LCD, multiply through, and I'll leave this as an exercise to the student. In general form, this is 25x squared plus 9y squared minus 200x minus 54y plus 256 is equal to 0. Now I will post this link for you. And there, that's a Desmos graph, and this is the graph. I have it drawn a little bit wider, but this is definitely to scale. And the vertices are exactly where we expect them to be, and the center is as well. So that is problem number 27. Okay, the next problem is number 31. You recenter. Okay, the given information from the sheet for number 31 is it's a hyperbola. Vertices of -1, 3 and -5, 3, and a focus at 0, 3. Okay, first thing we'll do with this one is take a look at the graph. Quick sketch, really. Okay, -1, 3. Vertex, -5, 3. This is a sketch. Focus at 0, 3. Well, this is going to have to open this way because the focus is on the transverse axis. Okay. Center is easily calculated halfway between these points at -3, 3. Now let's look at the given information. the distance between center and vertex is always the value of a in the hyperbola. That's 2. The distance between center and focus is the value of c. That is 3. Now, that's true in both ellipses and hyperbolas. That distance between center and focus is always the c value. Now, for the hyperbola, a is always the distance between the center and the vertex. It's not necessarily the longer or the greater of the two values of a and b, and in this case, it's certainly not, because in the hyperbola, the Pythagorean relationship is a squared plus b squared is equal to c squared. Now, substituting these values in there, that makes b equal to the square root of 5. All right, and then we can write the equation. X plus 3 over 2 squared, minus, this is the positive term because it opens side to side, y minus 3 over the square root of 5 squared is equal to 1. And again, exercise left to the student. 5x squared minus 4y squared plus 30x plus 24y minus 11 is equal to 0. A couple things about this is, again, the distance between center and vertex is the value of a. The value of b in this case is greater than the value of a. That's not uncommon in hyperbolas. It can happen. The positive term has the value of a on it because that's the way it opens. Always. There's another thing about hyperbolas is the slopes of the asymptotes is always the y dilation over the x dilation. It doesn't matter which one's a and which one's b. This is y over x every time. Okay, so we have asymptotes passing through with slopes of the square root of 5 over 2, which is a little more than 1 to 1. Okay, back to the Desmos. And we'll take a look at this one. Let me slide that up a bit so we can, I think that'll about do it. Turn this off, and I'm going to turn these on. Move that over so we can see. Okay, our center is at negative 3, 3. Vertices 2 in either direction. And these are equations just written in simple point slope form of, y minus 3 is equal to negative square root of 5 over 2 times x plus 3. Point slope form for both of those. And you can see that the asymptotes follow along the hyperbola. Okay. Next problem is number 35. This is going to be a tougher one. The given information for number 35, it says just a conic with a center of negative 3, negative 2, a vertex at negative 3, negative 7, and an eccentricity of 3/5. Okay, let's take a look at the graph of that one. Center negative 3, negative 2. Vertex negative 3, negative 7. That's a distance of 5, so we're going to have another vertex up here at negative 3, positive 3. Now, it doesn't specify here whether that's major or minor axis. It could be either. Okay? And actually, we can find one of each that'll satisfy these conditions. The easier of the two to deal with is the one where the major axis is in this direction. Okay, so we'll say the distance between here and here is 10. So 2a is 5, or 2a is 10, I should say. A is 5. Okay, the eccentricity is given as 3/5. Now on the ellipse properties sheet, one of the equations is C is equal to EA. We can take advantage of that. C is equal to EA, substituting values that we know to be here, 3/5 times 5, so C is equal to 3. And seeing how in the ellipse, a squared is equal to b squared plus c squared, b will be 4 from a simple 3, 4, 5 relationship. Okay, well then we can write the equation of this one as x plus 3 over 4 squared, y plus 2 over 5 squared is equal to 1. The major axis is vertical, minor axis is horizontal. I'm not going to plot all the points. You can figure that one out. Okay, so we have an ellipse that looks like this. There's also a possibility for this problem to have another ellipse that will have this is the minor axis, and it'll go out in sort of this direction. Okay, it's a quick sketch, and you'll see it when I put it up on Desmos. Now it's going to be harder to find. And so, for second possibility, all right, the value of b in this case is 5. Now the equation c is equal to EA has to hold. Well, we know that E is 3/5, so C is equal to 3/5 A. This equation also has to hold. A squared is equal to B squared plus C squared. Well, we can substitute into this equation things that we know. A squared is equal to 5 squared plus 3/5 A squared. Now 3/5 A is 9/25, so A squared, moving that over here, 9/25 A squared is equal to 5 squared. 7 over 25 A squared is equal to 25. Cross multiplying, dividing, or multiplying both sides by 25/7, I guess would be a better way of saying it, and then taking the square root, is A is equal to the square root of 625 over 7. Okay, now I can write the equation for this second possibility, and it's this. The value of A is the horizontal this time, so this will be x plus 3 over 25 over the square root of 7. Because that is the value of A, I can take that as perfect square. Plus, that's squared, y plus 2 over 5 squared is equal to 1. All right. We can transform these into general form. Now, I should have done this over here, but I didn't. So let me go back to this one first. Okay. Now I'm going to do this one a little bit differently than I did yesterday. Or I actually did this yesterday, but differently than using the LCD. I'm going to square 1/16 and then expand this binomial. X squared plus 6x plus 9. 1/25, squaring 1/5, y squared plus 4y plus 4, and that's equal to 1. Now that's going to give me 1/16 x squared plus 1/25 y squared. Then I'm going to have the x term of 6 over 16x, which reduces to 3/8 x. Then I'm going to have the y term of 4 over 25y. And then I'm going to have this combination of values, 9/16, 1/16 times 9, plus 4/25 minus 1. Okay. Now I put that into Desmos, and it's already there. You can look at that at your leisure. Let me slide this up. Try to keep it in frame. Put Desmos back down. Okay, turn these three things off, and then turn this one on. Oops, make sure that's off. Okay, so let me slide that up. And that is what we were expecting, okay? These points were given, well, no, actually, this one was given, this one was easily calculated, and then we found those two values from the minor axis. Okay. All right, well, the second possibility, and I can do the same here, and I'm just going to write this stuff down for you, and I'll leave this as an exercise to the student to figure out where all these values come from. And I'm just going to list them by their capital letters. A is equal to 7 divided by 625. Actually, I'll tell you where that came from. Okay, remember, we're going to square this value, which is 625 over 7, and it's 1 divided by that. So this is going to be the reciprocal of that, which is the leading coefficient if I did exactly what I did here. Okay, now the value of b, that is going to be this 7 divided by 625 times 6, which is part of the x squared plus 6x plus 9. Or that's not b, that's d, I should say. C is 1/25. That's just right here. E is 1/25 times 4, because y squared plus 4y plus 4. And F is going to be equal to, okay, we're going to have 7 divided by 625 times 9. So that's 63 over 625 plus 1/25 times 4. Y squared plus 4y plus 4. Okay, so this is 4/25. And then we're going to subtract the 1 just like we did the other ones. Okay, let me put that up there for you. Okay, I'm going to actually slide this a bit, and I'm going to put this in the frame, hopefully, and turn that on. Okay, now that involves, and it's hard to slide this thing on the iPad, but you can see it over here. We still have the same 2 vertices, and this one out here, and you can verify for yourself that the distance from the center to that point right there is 25 divided by the square root of 7. And you should look into that when you open this up for tomorrow. Okay. Now, that's a very difficult problem. All right. Next problem, and I'll post these notes again, is actually the easiest of the night. Let's recenter this thing. Okay, and that will be number the example is 44, which is a parabola with a focus of -1, 2, and a directrix of x is equal to 5. I was going to give you the example 43 and the homework of number 44, but I have this worked out, and I don't want to make a mistake at this point because, well, I'm so far into it. Okay. All right, so let's take a look at how this works out. Okay, just a simple graph. Focus at -1, 2. And directrix x is equal to 5. Now recall in the parabola d2 is equal to d1 because e is equal to 1. So that means that the vertex has to be in the middle of those two, probably more like here. Okay, halfway between -1 and 5 is 2. So 2, 2. Okay, now for a parabola, it's never going to open into the directrix. It's going to have to open in the other direction. The distance between here and here is 6 units. This was known as P. Let's go back to here. Okay. P is the distance between the directrix and the vertex, or the focus in the vertex. So P for this thing is equal to 3. Now another equation is that 1/4p is equal to the value of the leading coefficient in ax squared plus bx plus c. So 1/4p is 1/12, and that's equal to a. But this is a parabola that opens left to right. Well, we can easily deal with that. And since it's opening to the left, that means that this value is not going to be 1/12, it's going to be negative 1/12. And this is x is a function of y, so that's negative 1/12 times y minus 2 squared plus 2. The line of symmetry is the horizontal line, y is equal to 2. So this is a shift up, and that is a shift to the right. And you're familiar with it. We did talk about that before we left. And you're familiar with vertex form in y as a function of x. And this mirrors that to a degree. All right, your assignment for today is problems 28, 32, 36, and 43 off of the extra sheet. I will post the video and I'll post these notes so you can look at the notes, and because I don't know if this class or one of the other ones said that they're having a hard time seeing the stuff because I'm writing small. I don't want to write any bigger because I'm just not used to doing that. So I'll post the notes so you can look at them. All right, until next time.